Kia ora Year 12 and Year 11. I'm going to start working through the Level 2 Algebra paper from NCEA this year. I'm starting on question 2 and after that I'll do question 1. Now I'm going to hold off with question 3 for reasons that I can explain later on. But for now, let's look at this one. So I think the first part here is probably merit. Obviously the schedule's not out yet, but this feels like a merit question. And then this part is probably an excellence question. We've got Q of x, which is equal to fx squared plus gx plus h. F, g, and h are constants. For example, Q of x could equal 2x squared plus 5x minus 9, right? So that could be Q of x. And then we're told that the reciprocal polynomial is defined as this thing here with the coefficients in the reverse order. So Q star of x in this example would be negative 9x squared plus 5x plus 2. And that's equal to Q star of x. So it's not too scary as long as you're used to working with f, g, and h, or constants that are not numeric. So we have to find the solutions for Q of x is equal to Q star of x. I'm going to do this in about 4 different ways. I'm going to do it in the most efficient way, and then I'm going to do it in some ways that I think some of you might have tried. So if we've got Q of x is equal to Q star of x, then we have on the left-hand side fx squared plus gx plus h is equal to hx squared plus gx plus f. Now we can assume that f and h are not equal to each other, otherwise the reciprocal function is the same as the other function and we end up with 0 equals 0. Okay, so what can I do next? Well, we can see straight away that we've got a plus gx on both sides. So working quite slowly, we get fx squared plus h is equal to hx squared plus x plus f. Usually when we're working with a quadratic, we want to end up with everything equal to 0. So that's how I'm going to proceed here. I'm going to subtract this from both sides. That gives me fx squared plus h minus hx squared minus f is equal to 0. I'm going to collect up like terms and take out some common factors. So in here I get x squared times f minus h plus h minus f equals 0. But if you notice what I've got here, I've got f minus h here, and I've got h minus f here. I can rewrite this as x squared times f minus h minus f minus h is equal to 0. That gives me a common factor of f minus h. So we can take that common factor out the front, leaving me with this. So f minus h times x plus 1 times x minus 1 equals 0. And my solutions are x equals 1 or negative 1. Right, method 2 is to go back to, let's see, let's just go back to here. Right, so suppose you'd gone the same way until that point. You don't have to use difference of 2 squares. You could use the common factor here and just divide both sides through by that common factor. And you can do that because we've assumed that f is not equal to h. Right, so dividing through gives me x squared minus 1 is equal to 0, and then we continue in the same way. All right, so quickly, what about method 3? So these methods are kind of getting less beautifully efficient as we go. Let's go back up and assume that we'd got down to here, and then we'd kind of got a bit stuck. Well, actually, the method I'm going to do now is one where we don't make everything equal to 0. So, in fact, we'll suppose we got to here, and then we went, oh, well, what do I do now? The other thing that you might do is you might get the x squared terms on one side and the constant terms on the other side. So here we'd have fx squared minus hx squared is equal to f minus h. And hopefully here you'd notice that you've got a common factor of f minus h. And we'd get to x squared equals this, giving me x squared is equal to 1. And that's got 2 solutions. So x is equal to plus or minus 1. Now, the last way to do it is with the quadratic formula. You can do that, but the chances that you make a mistake in that are quite high. And I don't want to use up any more time on this part of the question, so I'm not going to do it. But I'll just show you quickly how you would. So if you get down to this quadratic, you've got A is equal to F minus H, and you've got C is equal to H minus F, and B is equal to 0. So then off you go. You can chuck that in there, and you'll get X is equal to 1 or negative 1. Right, but moving on to the more interesting part of the question, we are told that Q of X has got two different roots, A and B. And we're told that the roots of the other one are multiples of A and of B. So the roots of the reciprocal function are K times A and K times B for some constant K. Now, there are different ways to do this question, but the thing that this is screaming at me to do is to use an idea called the sum and the product of the roots. And I've done a video on that about 5 years ago, and it's something that comes up all the time in strange places. It comes up in hard level 2 problems. If you're watching this and you're doing level 3 calc next year, it can sometimes come up in the complex numbers paper. And if you're thinking about doing scholarship calculus, it comes up quite often in there as a really, really useful thing to be able to use. And it's not that hard, right? So I've put a little screenshot of the first page of that video in there, so you can go and search up that one. But basically the idea is that if we've got a quadratic, we can write it often in a couple of ways. So if I've got x squared plus 5x equals 0, I can also write that as x plus 2 times x plus 3 equals 0. And the roots in here are negative 2 and negative 3. And if you look at those roots, you can see that the sum of them is negative 5, which is the negative of this term here. And the product of the roots is equal to negative 2 times negative 3, which is 6. So we call that the sum and the product of the roots. And that's what I'm going to use to do with this question. Okay, so we're told that Q of X has roots A and B. So f of x squared plus gx plus h is equal to 0. I'm going to make this slightly easier by dividing everything through by f, so that I'm working with a quadratic with the x squared coefficient being 1. So that gives me this. And we know that the roots are a and b. That means that I could write this like this. And we know that these two things have to be the same. That means that the sum of the roots is a plus b, and that has to be the negative of this coefficient. So a plus b is equal to negative g over f. And the product of the roots is a times b, and that has to equal h over f. So if we're good with the sum and product of the roots, that's a pretty straightforward thing to write down once you're used to it, right? The roots are going to times to give me this thing here. And the roots are going to add to give me negative g over f. Now we've got the second polynomial, which is the reciprocal one. Let's go back to the question. And we're told that the roots of the reciprocal polynomial are ka and kb. So let's just write out what we've got. We've got q star of x is equal to hx squared plus gx plus f is equal to 0. I'm again going to divide everything through by h. I get x squared plus g over hx plus f over h is equal to 0. And I know that the roots of this are equal to x minus ka and x minus kb. Right, so these are the roots of the equation. When I shove in ka here, I'll get 0. When I shove in kb here, I'll get 0. So these two things are the same. And that means that I can look at the sum of the roots here, and I know that the sum of the roots has to equal negative g over h. So far I'm not wandering around blindly with this question, but I know that I can write down some statements about the roots in the two situations. So we've got Ka plus Kb, the sum of the roots in here, has to equal negative g over h. But I know something about a plus b from above, right? And I can see that I've got a common factor here of k times a plus b. So k times a plus b is equal to negative g over h. But let's go back to here, and we know that a plus b is negative g over f. So we've got k times negative g over f is equal to negative g over h. Right, we can times both sides through by -1, and we can divide both sides through by g. So that leaves me with k over f is equal to 1 over h. K is equal to f over h, and that's it. We're finished. I could have done that a different way. I could have used the product of the roots. It's slightly messier because you end up having to deal with a negative situation. But if you use just some of the roots, then we're finished. And if you go back to the question, what were we asked to do? Let's just check. We're asked to find an expression for k in terms of f, g, and or h. All right, so hopefully that makes sense. If you're watching this and you're finding this really, really hard, I think it's probably because you don't know how to use the sum and product of the roots. Pretty sure that you could get there in different ways with this question. You could definitely do it with the quadratic formula, but I think it would get messy. And actually I haven't tried it because I saw this way and I think this is a good way. So if you have done this in a different way, I am sure that you'll leave me a comment and let me know. Thanks for watching. Enjoy the rest of the holidays.